Okay, now we're gonna go over a betting strategy called the double down technique. So this video is a little off topic on our programming lessons here, but right here I just threw together a simple piece of code here that does the same thing as the last one, the last complex video here. So let's go ahead and run this here, and all it does is just enter a bet. So we have a coin, and we're betting against our friend here. So we make a bet of one coin here. Now whether it lands on heads or tails, we're either going to win or lose here. So right now I started off with 50 coins here. So I notice I initialized my coins to 50 here. So we won one. We're gonna continue to bet one here. So first we just bet one here. Then if we win, we're still gonna continue to bet one. We win, we bet one. This time we lost. So now that we lost here, we're gonna double down on our bet. So our bet was one here. We're gonna double that down to two. We lost again, so we continue to do so. We double down again. We bet four. This time we won here. So I'm not worried about the number of times that we lost here. We're only going to look at the number of times we won here. So we won a total of 3 times, right? Our base bet is 1 here. Okay. So the number of times we win is going to equal the number of times, the number of coins we have as our base bet. So if we won 3 times, we're going to have 3 more coins than we had. So if we started off with betting 2, we would have had a total of 6 coins, because our base bet would have been 2. So basically, it doesn't matter how many times we lost here. So here, let me show you a good example here. So we have 53 again. So I'm going to start, since I won here, I'm going to bet 1 again. We won again, we bet 1. This time we lost here. So we double down. We won again, we have 2. So we go down 1 here. I'll get to a point where I lose a couple times in a row. 2. Alright, so we bet again 4. We won again. 1, 2, 1, 2, 4, 8. Alright, see that? Okay, so right here, after my last win here, I had 57 coins here. Now, on my next win, I have 58 coins here, regardless of the number of times I lost here. So let's look at this here. I had 57 coins. Okay. I lost here. Now I had 56 coins. So I doubled down. I lost again. Now I have 54, which is minus 2 from the 56. So I double down again. I lost. Now I have 4. I lost 4 coins. I go 54 to 50 here. So I double down again. When I win here, I will win 1 coin here. So basically what I'm saying is this strategy, this betting strategy, is a way to make money here. We can make money if we find a person willing to make bets on flipping a coin, as long as we're willing, as long as we get to choose the bet. So since we won here, we start over. 1, we lost. 2, 4, 8. We won again. It's the same thing. 58 to 59. So regardless how many times we lost, 2, 4. Then we go to 1. Now, whether we win or lose, it's a 50-50 chance whether we win or lose. But when we're making money here, so we start off with 50 coins. Now we have 61 here. This is basically, this is an unbeatable strategy here. We have 50-50 chance here. All right. So I'm going to go ahead and, we can do this all day. We can make money all day on this game. 2, 4, 8. And look how many times I'm losing in a row. So I got to bet 16. See, look at this. I lost 4 times in a row here, which is a 1 out of 16 chance of losing. 4 times in a row is a 1 out of 16 chance here, but it'll eventually happen if you play all day. You'll eventually lose 10 times in a row if you play this repetitively. It's very common. 62. We went to 63 after our next win. So we're only counting the number of wins here. We won 13 times because I know I started off with 50 and I have a surplus of 63 coins. So these coins here, I'll explain this in a second. I'm going to close this here since this is an infinite loop, because I'm never going to lose if I use the strategy here. We'll always be making money here. So basically what this is going to mean here, this is going to be our surplus of coins here. So we have a surplus of 0 walking into a casino. So we might walk in with 500 coins, but our surplus is going to be 0 because the coins that I'm counting here are going to be the number of coins we walked out with. So if we walk in with 500 and come out with 0, our surplus will be negative 500, okay? If I had 500 coins and I walk out with 600 here, my surplus is 100 here. So right now, let's say we have a surplus of 0 here. So right here, it could be doing the same thing. Oh, here, let me change this to true here so we can play this game. And so we go to 1, we lost, so we double down. Oh, so we got a surplus of 1 coin here. So regardless of how many coins we start out with here, we're going to look at the surplus here. So let me change something here. I want to get rid of this piece here, and I just want to output an end line here. So let me show you a quick sample here. So now you might, this is something new here. This \t is a tab. The compiler will know that this is a tab, and we've already seen the new line characters here. This will output 2 new lines here. But what I want to do here, every time I win, because this is the part where I win here, the computer generates a random number here between 0 and 1, because it's a mod 2. We can only pick characters from 0 to 1. 1 is going to represent a win, 1 is going to represent a loss. If we win here, we're going to set our bet equal to 1 here. If we lose here, we're going to take the loss of our bet, and then we're going to double our bet. Bet is times equal 2. Now, if you didn't watch the increment decrement video, this is the same thing as bet times 2. We double our bet here. It's the same thing. You can use either one you'd like, but they're the same thing here. Times equals 2. Now, what we're going to do here, I want to make another variable here. I'm going to make a double variable. Let's say we call it count, and we set it equal to 0 here. Now, just to show you how much money we can actually make here in a second here. So we have double count is equal to 0 here. And then, yeah, that's the other thing here. I want my count. Yeah. Let's say while count is less than, let's say, 1,000 here. So we're going to run this code 1,000 times here. And then when we get through one game here, a game is going to be a flip of a coin in this case, or I should say yeah, it's a game. So we're going to run this 1,000 times here. What's going on here? Oh, it's less than here. So we're going to increment this 1,000 times here. Now let's run this here. Now before we do that here, I want to output. So we have I want to output 3 new lines here, along with the coins divided by the count here. This will just be a rough estimate on how much money we could make if we're making any money per roll here, because this is going to be 1,000 here, right? 1,000 games. Our surplus divided by the number of games is going to be our average amount, the average amount of money we can make here. Oop, is being used without. Yeah, okay. Here, I gotta. Here, something's wrong here. I gotta set this equal to 1 here. My operating system will. Actually, it won't be that bad. It's just a value. So basically, what this did here, it simulated 1,000 games here. Now look what it printed to the screen here. It printed out 0.5 exactly here. Okay. So here I'm gonna put a new line here. That way we don't have to see the system pause right below it. Let's run this again. We're going to run 1,000 times through here. This time we got 0.482. So last time we got 0.5, last time we got 0.482. So we're making money here. We expect to be making a half a coin for every roll here. Now, if we walk into a casino and we come up with a strategy to beat a game here, as long as this is positive here, as long as this number is not negative here, we're making money and we can take that game. Right, if we're able to come up with a strategy depending on the game, like maybe the roulette wheel or the blackjack. Here, so here, let's say we instead of doing 1,000 games, let's say we do 10,000 games. And this executes kind of slow. Why is that? Because look how long it's taken here. It has to print all this stuff to the screen here. That's what's taking the most amount of time here. So it's keeping track of all this here, and it's keeping track of the number of games I'm playing. Basically, because that's going to be represented by my double count. And keep in mind that when I take so I get about 0.05 again, right? Well, here, watch this. Just to speed this up here, let's say we get rid of all this C out stuff, console output stuff here. It's all going to go away here. We get rid of all of it, except for the last stuff. Now when you run this again, look how fast it can execute 10,000 games. Because it doesn't have to print all that to the screen here, it does it instantly. So we can get a very large sample size of these here. We got 1 million games, let's say we do 10 million games here. Or is that, I'm at 1 million, right? How many zeros? That's 1 million games here. Let's say we do 10 million games. It can do 10 million games almost instantly. I saw a slight pause there. But we can do 1 billion games here. Watch how fast it does 1 billion games here. 1 billion games. It's taking a little bit. See that? 1 billion, but it still does it pretty quick. So we get about 0.5. Our expected value is 0.5 here. So we will make, if we're able to find somebody that will be willing to play this game with us, if we found somebody that would just make bets, and as long as we get to choose the bet, we can do this all day and make money. So if we here, let me output the number of coins here below this, just to show you one more thing here. So right here, I want to output, let's just say coins here, and coins is our variable that's going to be printed to the screen here. So we're going to output 10. We're going to output 1 billion coins here. Now look at this here. We have 3 here. We got 6 here. Wait, is that 10 billion? Oh wait, how many? We got 3. 6, oh no, I'm sorry. This is 100 million here. It's not a billion. It's 100 million. I don't want to execute 1 billion games of code because it'll take a while. All right, so the last time we executed 100 million coin flips here in a couple seconds. And now this time we're getting pretty close to 50 million coins, right? Well, our expected value is exactly 1/2 if we do the math. But we can also just let the nature of random numbers do this calculation here. We get about 0.5. We get an approximate value of 0.5 here. Now again, I'll show you how to display more digits here, so we can get 15 digits accurate when we do the math here. But basically, we're gonna get however much money we're gonna walk in with. If we play 1 million games, if we have that much time, we're gonna walk out. If we play 100 million games, we're gonna walk out with 50 million here. Approximately. If you played 10 games using this strategy here, you will be expected to walk out with 5 coins, right? Well, it won't happen every time, right? Because you might lose some. You could lose 5 times in a row and come out less. But if you play this enough time, you're gonna approach a limit, and that happens to be 1/2 over time. So the problem with the strategy is that you'll need a lot of money to back up your funds. And the other thing is you'll need to find somebody to play this. Now, if you ever played the roulette wheel, there's 36 numbers. Actually, there's 38 numbers, and there's 2 green zeros. So basically, if you bet on red or black, you can bet on red numbers or black numbers. Let's say we're just going to bet on a red number or a black number. Well, it's almost 50-50, right? Now, I'll show you later what happens when we do this here, to see if we can actually make money from it. So it's almost 50-50, right? We almost have a 50% chance, but still the house has a slight advantage because they're going to take everything that's on the table when it's green. Assume that nobody bets on green. So we'll go over that in a second. We'll see. So basically, if we found a casino game that played this coin flip game, as long as this value is above 0, we're making money. It doesn't matter what it is. If it's above 0, we're going to be able to make money and take the house. But if it's negative, which it probably will be, you're going to lose money. Then you're gambling. You're only gambling if you know it's negative and you still make the bet anyway. It's not gambling if the odds are in your favor here. In this case, the odds are in our favor because we're making the bets, and because we're making bets that are going to be in our favor here, just on this simple game here. So that wraps us up, and we'll get back to arrays, and we'll eventually get to the functions here in the next couple tutorials. So you might be able to, hopefully you might be able to talk one of your friends into playing this game with you. Especially, well, anyway, I'm just going to wrap this up right now.